Okay, students. Now, in today's lecture in the morning, we study source transformation method. The purpose of the source transformation method is to make the circuit more simplified. It's a powerful tool actually. So, basically, you can manipulate the circuit. You can modify the circuit according to some basic rule. So the rule is that a given circuit, okay, if it has a source like this, okay, with a resistance in series which is R, okay, so basically in terminals AB it can be equivalently drawn or represented as a current source, okay, so which has a value, okay, the current direction would be towards the positive, so this is current, right, and then the resistance would be connected in parallel with R, and this with the current source, and these are your terminals. Now these two are, okay, electrically equivalent to each other. Why? Because they satisfy the VI characteristics, okay, they satisfy your characteristics at this terminal. So for instance, if we, let's suppose, if we remove if we switch off, okay, the sources in both circuits, okay, in this source, okay, in both circuit, in this circuit the source is V. So if I switch it off, so basically this would be, by switching means that it is would be voltage would become what, short circuit. The voltage is always, remember, it would become short circuit. And current, we always, when we switch off the current source, we always make it open circuit, so this is short circuit, right. So it means that, okay, the value of resistance between A and B is R over here in this figure, in this circuit. And the value, again, if you do the same, apply the same concept over here, we switch off the current source, it may be make it open circuit. So if we make it open circuit, so the only thing we left is this R, right, this R, and we don't consider this circuit. So if actually the effective value of the resistance between A and B is again what, R. So basically R over here, R over here. So if some current passes, the same voltage drop will be will get across. So basically you satisfy the Ohm's law. And similarly we say that they are both equivalently similarly to each other, equal to each other. So basically we can do transformation from voltage source to current source and vice versa. Now we'll do an example. An example is given in the book, right. So in the book it says, so if I remove this thing now, okay, 4.6 it says, okay, this is example 4.6, okay. Now it is given that use source transformation to find V naught. So V naught is the voltage across the 8 ohms resistance, okay. We need to find 8 ohms, the voltage across 8 ohms resistance using source transformation. So the other methods, okay, uh, which will be the same as source transformation, is your mesh analysis, which we done last time, and nodal analysis, which we also did last time, okay. So source transformation is another way, okay, to solve a circuit and to find a circuit value such as V naught, which is actually V at the voltage across the 8 ohm resistance, which is equal to I into R. So basically I we need to find, and R is the value of the current, which is this, which is 8 ohms, right, which is 8 ohms. So we need to find the current in this branch. So we can apply mesh analysis, we can apply nodal analysis, but over here it says use source transformation, because this is sometimes becomes more easier to apply this transformation method. So for that, what we can do, we can, if you see these two branches, they are in parallel, one is current source, the other is the parallel resistance value. So I can convert this into a voltage source with a plus, minus, and plus sign, arrow sign. Then I can connect this as 4 ohms, right. Then I have then 2 ohms resistance, okay. Then I have this 8 ohms resistance, and then I have this 3 ohms resistance, and then I have plus minus okay, the value of this is 12, right? And then I can connect all of these together over here. Okay, now remember, now these two resistances are in series, so I can, okay, what is the value of this voltage source? So remember, it can be, I can, this voltage source by definition is equal to IR. What is the value of I? Current, which is 3, okay, and the value of this is 4, so this is basically 12 volts. So the way this is 12 volts, okay. So this is 6, so I can redraw this circuit, that this is minus, this is plus, this is 12 volts, this is 6, right? Okay, this is then 8, this is 3, this is plus minus 12 again, this is 3. So now if you see, okay, I'm interested in the current value over here, in the current value over here, okay, the current value over here. So again I can apply source transformation on this branch, okay. So if I apply a source transformation on this branch, right, so you can see, I can, if I can come over here, so I can convert this source, voltage source, into a current source, okay, and then the 6 ohms resistance I can make it in parallel, okay. Then 8 ohms resistance, I have 8 ohm resistance, right. Then okay, now I can also, okay, over here, from here, if you see, I have this in a series voltage source and connected in series with the resistor, so I can this make it in parallel, okay, and then I can make again this source as a current source, okay. So basically, if you see, I apply two transformation, one is add over here and one is add over here, okay. So this is from one transformation and this is from the other transformation, right? So sorry, sorry. Right. So basically, now what is the value, what would be the values of these currents? But remember, if the plus sign is over here, so I would, if you see, I would make this arrow, okay, over here. So basically this is my current source which is going up, okay. What is the value? The value would be over here would be I equal to V divided by R. So I equals to, the value of V is 12 divided by 3, okay, it will be 4 ampere, okay, this is 4 ampere now. And what is the value of this? It would be again I equal to V divided by R. What is V? Which is 12, okay, so I is equal to 12. What is R? R is 6, so basically this is 2 ampere. So this is my 2 ampere. Now if you see, they make a common node over here, so basically 2 ampere comes out and 4 amperes gets in, so the net current would be equal to 4 minus 2, which is equal to 2 ampere. So I can replace these two sources by a single source, which will be equal to single source, and then I have 6 ohms, then I have 8 ohms, this is 8, 6, this is 6 ohms, right, and then this is basically 3 ohms, okay. So basically I can connect, this is 2 ampere current, okay, 6, 8, and this is, remember, 3 ohms, right. So this is how, okay, this is how we can proceed further now. Okay, now after, if you see, after this is this was the circuit, okay. So now we have 3 resistances in parallel, okay, and we are interested in current in this I8 ohm branch. So I can replace this resistance and this resistance by single resistance, and remember these are in parallel, so the equivalent resistance would be, this would be R1 into R2 divided by R1 plus R2, which is equal to 6 into 3 divided by 6 plus 3, so 18 divided by 9 is equal to 2. So I can replace this by, so I can redraw the circuit. I can say, okay, this is my 2 ohms 2 ampere current source, and then it would be my resistor, which is now the value is 2, remember, and this there will be another resistor over here, remember, and this is 8 ohm resistor. So I'm interested in the current over here. So if you see, if the current goes over here, it would get distributed into two branches. So applying current divider rule, I can say the current in the 8 ohm resistance would be the total current times the resistance in the opposite branch, which is 2, divided by the sum of the resistance, which is 10, right? So basically this is 4 divided by 10, which is 0.4 ampere. So the current over here is equal to 0.4 ampere. Now what should be the value? So this was the current 0.4, okay, multiply by 8. So if you do like this, the voltage would be equal to 3.2. So at 432 it would be 30. So the voltage get across this is equal to 3.2 volts. So source transformation, it means the source transformation is a powerful tool to analyze a circuit, okay. So you can transform a a voltage source like over here to a current source, right, to a current source like over here, and or a current source to a voltage source. So they are both vice versa, and they satisfy they simplify greatly the circuit. Thank you.